Good afternoon, all. I'm Bhavanesh Athikary, Automotive Lead, Indo-Pacific Hexagon MI. Today, I'll be talking on how Hexagon can help you accelerate e-mobility design and manufacturing. Let me start by introducing who we are. Hexagon is a global leader in sensor software and autonomous technologies committed to empowering an autonomous future. So, this slide isn't to explain the past industrial revolutions. It's to illustrate where we are and where we are heading. A revolution that Hexagon is leading, from automation to autonomy. Why is this so important? The technologies we love the most are the ones which we don't have to think about, the ones that think for us. This is why we are focused on autonomy. It's the ultimate form of putting data to work, which leads to the greatest gains in efficiency, quality, and productivity, which are the very outcomes our customers seek. This slide talks about our core competencies. Sensor solutions for data capture, software solutions for data intelligence, and autonomous solutions for data leverage. Before getting into the acceleration part of e-mobility, let me highlight what are the key challenges today we have in design and manufacturing of e-mobility. The first and foremost challenge is range anxiety. So this can be addressed to powertrain optimization, battery thermal management, lightweighting aspects, tire rolling resistance improvement. So there are a lot of areas where design can influence range anxiety. The second most important point here is manufacturing and quality assurance. So here, there are a lot of new parts which are coming into EVs, right? So from the battery manufacturing to the powertrains, so the way it is manufactured, the manufacturing processes, they are new, so there is challenges there. Joining of dissimilar materials and improving productivity and efficiency with smart manufacturing solutions. The third one is on driver and passenger expectations or experience expectations. So there is a high amount of expectation in terms of cabin comfort, the ADAS features availability, infotainment, and telematics. The final point is on vehicle performance and safety. With the battery systems and a lot of electronic components, the way it is assessed for safety is different, and that's another key challenge: EMI protection, battery safety, thermal management, and leakages. Hexagon's approach is to address these challenges in a holistic way by bringing in the key pillars of product development, that is design and validation, manufacturing, and quality. Let me give you a brief of each of these verticals. So design and engineering is mainly on the simulation side on how we can influence at the concept design stage of the product development. We have a comprehensive set of e-mobility focused simulation solutions addressing different physics and challenges like battery thermal management, e-powertrain noise, lightweighting, structural safety, and advanced driver assistance systems. From a manufacturing point of view, it's important to address the manufacturing process parameters upfront in the design cycle. So here we help you to optimize these manufacturing process parameters for different manufacturing processes from the concept design stage. To give you an example of a welding process, you would want to know what's the optimum path in which it needs to be welded, the clamping location, the number of clamps, so that the defects like the distortion because of the welding, residual stresses are addressed. Well, my belief is that materials will shape the future of EVs. Today, range, cost, and performance are the three important factors that are driving material selection. Industry is exploring beyond the conventional materials used today. So there is also a lot of focus in making EVs more sustainable, not only from the energy consumption and emissions point of view, but also from material circularity and toxicity. So the third vertical is on quality. So with a lot of new components coming in, the way they are measured is different, and the components or the devices used for their measurements are also different. So there are a lot of challenges related to that. These are some of the e-mobility components highlighted here on and how the quality assurance is taken care of. So that was about external inspection. We also need to ensure internal inspection, and that is done through computer tomography studies. Like what you're seeing here in this slide, it'll help you to measure or check quality without destroying them in a non-destructive way. So use cases can be many, some safety critical parts like battery systems, where ensuring the quality of the battery by looking into it for inclusions and defects in anode, overhangs, etc. So, well, those were the three important verticals of product development. And our unique value proposition is connecting design and engineering, manufacturing, and quality with continuous improvement loop for ensuring your end product is as designed. So we have workflows built for each EV subsystem in line with the concept discussed in the previous slide for electric motor, drivetrain, power electronics, battery and fuel cells. Similarly, for vehicle level developments in terms of new material development, cabin interiors, exterior and aerodynamics, and body structure. So another important or interesting topic is the influence of AI and ML in the EV development. So one use case is definitely with a lot of information coming from manufacturing, testing, and also simulation, how to use that data intelligently to take an augmented decision. That's where your AI ML algos can help you. Another important application of AI ML methods have been on increasing the efficiency of your simulation solvers through reduced order models. This is a use case of a battery impact and short circuit analysis. This is a multiphysics case with structural, thermal, and electromagnetic field involved. So here, if you look at the compression deformation and the terminal voltage, the temperature distribution, it's a 98% match with 1% of time required for an FEA analysis. So it's possible to dramatically reduce the simulation cost by using such reduced order models. It also finds application in areas like digital twins. There is an increased expectation for e-mobility to be smart, loaded with ADAS features. Hexagon's autonomous vehicle solutions helps you to design and validate both virtually and physically different levels of autonomy or ADAS features. Another interesting offering is on the consulting and services of e-mobility. We cover from concept to detailed design, evaluation, assessment of material and technology, life prediction and safety of e-powertrain, motor, power electronics, controls, and instrumentation. These are some of the use cases of turnkey e-powertrain platform development for 12 to 36 tonner commercial vehicle. This is an example of a multi-speed e-powertrain for premium electric SUV. This is another multi-speed transmission development for hybrid EDU and transmission development for mild hybrid EDU. So these are some of the examples. So that's all I had for today. Thank you all. I'll be happy to address any questions you may have. Thank you.